Earthquakes. Earthquakes occur when energy stored in the crust releases suddenly along fault lines where tectonic plates meet. These massive slabs of rock are always shifting, driven by convection currents in the semi-liquid mantle below. When plates grind against each other, enormous pressure builds until it exceeds the strength of the rock. At this breaking point, the fault ruptures, releasing seismic waves that radiate outward. Depth plays a critical role here. Shallow earthquakes typically cause far more destruction than deeper ones because the seismic energy has less distance to travel before striking the surface. These waves come in several forms. Primary waves compress and expand the ground, secondary waves create side-to-side motion, and surface waves cause the most damage to structures. The most destructive earthquakes often occur at convergent boundaries, where one plate slides underneath another. The 2011 Tohoku earthquake in Japan, which registered a magnitude 9.1 and triggered a devastating tsunami, occurred along such a boundary. Transform boundaries, where plates slide horizontally past one another, like California's San Andreas Fault, produce frequent but typically less powerful earthquakes. Beyond their immediate shaking, earthquakes trigger numerous secondary hazards. Liquefaction occurs when water-saturated soil temporarily behaves like a liquid, causing buildings to sink. Earthquakes can trigger landslides, avalanches, and tsunamis. Underground utility lines rupture, causing fires and water main breaks. Despite technological advances, earthquakes remain among the deadliest natural disasters, claiming hundreds of thousands of lives when they strike densely populated areas with inadequate building standards. Volcanoes. Volcanoes represent Earth's pressure valves. They are points where molten rock, gases, and ash escape from the planet's interior. These fiery mountains form where magma rises through weaknesses in the Earth's crust. The most active volcanoes cluster along tectonic plate boundaries, particularly in the Ring of Fire encircling the Pacific Ocean. Eruptions happen in two main ways. Some are gentle, with running lava flowing out slowly to build wide, flat mountains like Hawaii's Mauna Loa. Others are violent and explosive, blasting ash and rock to build tall, steep cones like Mount St. Helens. The difference comes down to the magma. If it's thick and sticky, it traps gas bubbles until they burst explosively. If it's runny, the gas escapes easily. The deadliest volcanic hazards often come not from lava, but from associated phenomena. Pyroclastic flows are avalanches of hot ash and gas that race down the mountain at hurricane speeds and can exceed 700 degrees Celsius. Lahars, volcanic mudflows, can travel great distances along river valleys, burying communities. Volcanic ash clouds pose significant modern hazards, particularly to aviation. Scientists monitor active volcanoes using seismographs to detect earthquake swarms, GPS systems to measure ground deformation, gas monitors to track changing emissions, and satellite observations to note temperature changes. While these techniques can identify increasing activity, precise prediction remains challenging. Tsunamis. Tsunamis, from the Japanese words for harbor and wave, represent nature's most powerful water movements. Unlike wind-generated waves, tsunamis involve the entire water column from surface to sea floor. They begin when a massive disturbance, typically an underwater earthquake, volcanic eruption, or landslide, displaces an enormous volume of water. The most common tsunami trigger is a megathrust earthquake along a subduction zone. When a section of sea floor suddenly uplifts or drops, it displaces the entire water column. In the deep ocean, these waves travel at 500 to 700 miles per hour while remaining almost imperceptible on the surface, typically less than a meter high, but hundreds of kilometers long. The tsunami's destructive transformation occurs as it approaches shore. As waves enter shallower water, their speed decreases while their height increases dramatically. The leading wave may initially cause the water to recede from shorelines, followed by the arrival of massive waves. While typical tsunamis reach heights of 3 to 10 meters, extreme events can produce a run-up, where water rushes inland, reaching heights of 30 meters or more. Tsunami damage extends far beyond the immediate coastline. The water becomes a debris-laden slurry that picks up vehicles, buildings, and trees, increasing its destructive power. When the water finally recedes, it scours the landscape, often changing coastlines permanently. Modern tsunami detection systems employ pressure sensors on the ocean floor that measure changes in water pressure as tsunami waves pass overhead. Despite these advances, tsunamis remain among the deadliest natural hazards, particularly when warning systems are inadequate. Hurricanes. Hurricanes, also called typhoons in the Western Pacific and cyclones in the Indian Ocean, represent nature's most powerful storms. These massive tropical cyclones form over warm ocean waters when specific atmospheric conditions converge, such as sea surface temperatures above 80 degrees Fahrenheit, high humidity, light winds overhead, and a location at least 5 degrees latitude from the equator. The storm begins as a tropical disturbance, a disorganized cluster of thunderstorms over warm water. As warm, moist air rises and cools, it releases latent heat, warming the surroundings and causing more air to rise. This self-reinforcing process gradually organizes into a rotating system with a clear center. A mature hurricane operates like a heat engine, drawing energy from warm ocean waters. At the storm's center lies the eye, a relatively calm area typically 20 to 40 miles across. Surrounding this is the eye wall, where the most intense thunderstorms and strongest winds occur. The primary hurricane hazards include extreme winds, torrential rainfall, storm surge, and inland flooding. Perhaps the most dangerous element is storm surge, an abnormal rise in sea level as winds push water toward shore, often compounded by the storm's low pressure. As Earth's temperature rises, warmer oceans provide more fuel for storms, potentially increasing their intensity. At the same time, rising sea levels worsen storm surges, while a warmer atmosphere holds more moisture, leading to heavier rain. Tornadoes. Tornadoes represent nature's most violent atmospheric phenomena, spinning columns of air that connect storm clouds to the ground, bringing winds that can exceed 300 miles per hour in extreme cases. These vortices develop primarily from supercell thunderstorms, where a persistent rotating updraft called a mesocyclone forms. A tornado starts when wind shear, winds moving at different speeds or directions, creates a rolling tube of air. As warm, moist air rises within a thunderstorm, the storm's updraft tilts this tube vertically. If it tightens and touches the ground, a tornado is born. The United States experiences more tornadoes than any other country, with Tornado Alley in the Great Plains being particularly prone to these storms. Here, cold, dry air from the Rockies clashes with warm, moist air from the Gulf of Mexico beneath strong upper-level winds, perfect conditions for supercell development. Tornado intensity is measured on the enhanced Fujita scale, ranging from EF0, 65 to 85 miles per hour winds, light damage, to EF5, over 200 miles per hour, catastrophic damage. The most violent tornadoes comprise less than 2% of all tornadoes, but cause approximately 70% of tornado-related deaths. When a tornado passes over a structure, the extreme low pressure creates an explosive effect as higher pressure inside pushes outward. Simultaneously, intense winds create both crushing forces on windward walls and lifting forces on roofs, and flying debris becomes high-velocity projectiles capable of penetrating walls. Floods. Historically, floods claim more lives globally than any other natural disaster. These occur when water overwhelms land that is normally dry, ranging from gradual river overflows to catastrophic flash floods that arrive with little warning. River floods happen when too much rain or melting snow fills a river until it spills over its banks. Flash floods are more sudden and dangerous. They can happen in minutes when heavy rain falls faster than the ground can soak it up. Urban areas are particularly vulnerable as stormwater systems become overwhelmed. Coastal flooding occurs when storm surge, high tides, or tsunamis push seawater inland. For example, Hurricane Katrina's 2005 storm surge overwhelmed New Orleans' levee system, flooding 80% of the city with up to 20 feet of water. The danger isn't just the high water. Floodwaters are often toxic, mixing with sewage, chemicals, and germs that can make people sick, and the physical force of moving water destroys infrastructure, undermining bridge foundations, and washing away roads. Wildfires. Wildfires are uncontrolled fires that burn through forests and grasslands. While they can be destructive, fire is actually natural and necessary for some ecosystems to clear out old brush. In nature, lightning or volcanic activity usually start fires, but today, humans cause about 85% of them through accidents or carelessness. Fires spread differently depending on the wind and terrain. They race uphill very quickly because the heat rises and dries out the plants above. Wildfire behavior varies tremendously. Ground fires burn organic material on the forest floor, while surface fires consume grass, shrubs, and small trees. Crown fires, the most intense and dangerous, leap from treetop to treetop, creating their own weather systems through convective heat. The role of fire varies across ecosystems. Many forests depend on periodic low-intensity fires to clear understory vegetation and release seeds. Grasslands rely on burning to prevent encroachment by woody species. However, fire suppression policies interrupted these natural cycles in many regions, allowing dangerous fuel accumulation. Drought. Drought is a creeping disaster. It happens slowly when an area doesn't get enough rain over a long period. Unlike a storm that hits and leaves, a drought can last for years. It starts with less rain, a meteorological drought, which dries out the soil, an agricultural drought, and eventually lowers rivers and reservoirs, a hydrological drought, with socioeconomic drought emerging when water shortages affect human activities. The worst droughts often occur when a high-pressure weather system gets stuck in one spot, blocking rain clouds from entering the region. This is exactly what happened during the Dust Bowl of the 1930s. A high-pressure ridge repeatedly formed over the central United States, diverting moisture away from the Great Plains for consecutive summers. Drought impacts cascade through natural and human systems. Plants reduce photosynthesis, wildlife concentrates around dwindling water sources, and groundwater extraction accelerates, potentially causing permanent aquifer damage. Human impacts begin with agricultural losses but extend to broader sectors. Hydroelectric generation declines, water-dependent industries face production constraints, and municipal water restrictions affect quality of life and business operations. Blizzards. Blizzards combine three dangerous elements: heavy snow, strong winds, and frigid temperatures, creating conditions where survival outdoors becomes questionable within hours. These winter storms transform familiar landscapes into otherworldly environments, where visibility disappears and the simple act of walking becomes risky. Meteorologists define a blizzard as a storm with winds exceeding 35 miles per hour, visibility reduced to less than 1/4 mile by snow, and conditions persisting for at least 3 consecutive hours. Blizzards typically develop when powerful low-pressure systems draw Arctic air southward while simultaneously pulling warm, moist air northward. The danger isn't just the amount of snow, it's the wind. It blows snow into massive drifts that can be 20 feet high, easily burying cars and blocking doors. The wind also creates a dangerous wind chill, which pulls heat away from your body much faster than calm air, causing frostbite in minutes. The scariest scenario is when the storm knocks out power lines, leaving people without heat in freezing conditions. Fortunately, modern forecasting has dramatically improved blizzard prediction. Computer models now reliably forecast major winter storms several days in advance, while Doppler radar and satellite imagery track storm development in real time. Avalanches. Avalanches release enormous energy as tons of snow and ice cascade down mountain slopes at speeds reaching 80 miles per hour. These white tsunamis transform serene winter landscapes into lethal terrain in seconds, burying everything in their path. Avalanches require 3 elements: a lot of snow, a slope that is steep enough to slide, usually between 30 and 45 degrees, and a trigger to kick it off. Triggers can be natural, like heavy new snow or rain making the pack too heavy, but often the trigger is human, a skier or snowmobile hitting just the wrong spot. The real danger lies hidden underground. Snow doesn't fall in a single block, it builds up in layers over the winter. Sometimes a weak layer forms deep inside the snowpack. Imagine a layer of loose sugar or marbles buried under heavy slabs of concrete. If that weak layer collapses, the heavy snow on top breaks free and slides down the mountain. If you get caught, time is your main enemy. When an avalanche stops, the snow sets like concrete. If you are fully buried, you have a 93% chance of survival if found within 15 minutes. But after just 35 minutes, that chance drops to only 30%. Most victims die because they run out of air, though the physical impact causes injuries too. However, technology has improved survival odds. Modern gear includes beacons that help rescuers find you electronically, and inflatable airbags that help you float to the surface of the moving snow instead of getting buried. Landslides. Landslides happen when gravity wins the battle against the ground holding a hill together. This can be a slow, creeping movement you barely notice, or a sudden catastrophic collapse that sends rock, soil, and trees racing downhill. While gravity is the main driver, water is usually the trigger. When heavy rain soaks into the ground, it acts like a lubricant, reducing friction between soil particles until the slope can no longer hold its own weight. Landslides come in many shapes and sizes. Rockfalls are individual rocks breaking loose from a steep cliff. Debris flows are dangerous, fast-moving rivers of mud, rock, and water that can travel for miles, wiping out everything in their path. Earth flows are slower, moving like thick, wet concrete. Humans often make the problem worse. Trees act like natural anchors, holding soil in place with their roots, so cutting them down makes slopes unstable. Carving roads into mountainsides or digging for mines can also weaken the ground, making it more likely to slide. Sinkholes. Sinkholes are nature's trapdoors, places where the ground suddenly collapses without warning, swallowing cars, houses, or roads. They usually happen in areas where the rock underground is soft, like limestone. Over time, rainwater, which is naturally slightly acidic, soaks into the ground and eats away at the rock, creating underground caves. As the cave gets bigger, the ceiling of dirt on top gets thinner and thinner until it can't hold its own weight anymore and snaps. Humans often trigger sinkholes by accident. Pumping too much water out of the ground removes the pressure that helps hold the roof of the cave up. Building heavy structures on weak ground can also cause a collapse. Because they happen so fast, they are hard to predict. However, there are warning signs. Circular patches of dead grass, where water is draining away too fast, small holes appearing in the ground, or doors and windows in your house sticking because the foundation is settling. Thanks for watching. Don't forget to like and subscribe and click here to check out this video on the deadliest tornadoes in US history.